Hello everybody, welcome back to another edition of the Modicon M221 training. I'm your host, Leandro Mada, and in this video what we're going to see is how we can communicate the Modicon M221 with a TeSys Island. Okay, so due to this shortage of products of the TM3 modules, so some people had advised to use the TeSys Island, the analog inputs and outputs and digital inputs and outputs of the TeSys Island to communicate with the M221. The thing is that there is no integration inside the software of the EcoStruxure Machine Expert Basic that allows you to easily define the device of the TeSys Island that we have as like the bus coupler. So I'm going to show you how we can do this. So the first thing that we need to know is that I need to open on my side this and this. So the first thing that we need to know is that how we can access to the information from the TeSys Island. So I recommend you to take a look into this manual, okay, which is the TeSys Island, but for Modbus TCP third-party integration. So here we have a real explanation how to access to everything inside, but my main focus here is not going to be the starters or the safety part. It's just how we can communicate with the IOs. Okay, so the first thing that we need to know is that each device in the or each module in the TeSys Island configuration has a unique ID. So if we go to Modbus TCP addressing, here you can find some definition about the different avatars. Okay, so each module is called an avatar. So each avatar will have a unique ID, so you can find information there. In this list, okay, you can see that some definition about the order in the configuration. But what we need to take a look is this one. If you go to device information, you have digital I/O and analog I/O. So if we go to digital I/O, this is an idea how you can access to the information. So depend on the location of the device or the module in the configuration of the TeSys Island, you will need to read this information and write this information, and read this information in order to get the status of the digital inputs. And something similar is with analog IOs. Okay, you can see here all the registers. So what I'm going to do is to show you now is I'm going to open the SoMove. Okay, I have this TeSys Island with me. So I have the bus coupler, I have the analog I/O, and I have the digital I/O. These modules, even if they are in the same rack, are not connected to the device. You see here, it's not connected. So I'm going to focus only in these three. So if I open the SoMove, okay, the IP address for the device is this one. So I should be able to scan the network, see the TeSys Island. Okay, you should read all this. Okay, and I'm going to explain what is a TeSys Island, how to configure. No, I'm just going to show you how to make the integration with the M221. So the first thing that you need to do here is the M221 doesn't have Ethernet IP. The M221 can only be adapter. So in the communication, what we need to check is they are in the same network, and the protocol, okay, is Modbus TCP. Okay, so my avatar, you can see here the avatars that I have connected right now, and the field bus protocol is Modbus TCP. If you're using Ethernet IP, this is not going to work. So as you can see here, I use the analog I/O, which is just change the view. The analog is the first one, and the second one is the digital. Okay, so once you know the location of these devices, Okay, you can see here position 2, position 3, but it's going to be the ID 1 and 2. So what I have done is try to put this in a simple way. I'm going to disconnect from here, and I open this Excel I have done. So there is two ways to communicate with the TeSys Island. Okay, one way that I'm going to explain now is going to be the easiest one, because each device on the location on the rack will have a unique ID, and then using that unique ID you are able to access to the information of each parameter based on this table, okay, for an iOS. The other way would be to point to the bus coupler, okay, and then get access to the information inside, but that's going to be a little bit more hard. So based on this, okay, you can add analog type, digital, and you can see the reading position that you require. Okay, in my case, I have only an analog IO and a digital IO, and the avatar unit ID is going to be 1 and 2 for this one, because the system, the bus coupler has the unit ID 255. So in our configuration in the software, okay, if we go back here, okay, we need to add the bus coupler, okay, the device, the generic device, as a generic device, if you're using the IO scanner. And then what is different is the unit ID. This unit ID must match to the one that we have over here, okay, this one. And then what we need to change is the channels, because the information on the channel will depend on the information on each device. Okay, so let's try to do this. So I'm going to open this application over here, the other way here. So inactive. So here I'm going to use this IP address, the same I'm using right now, .21, and I believe this one is the ME16T. Okay. I'm going to enable this port. And now the IP address of the TeSys Island bus coupler is going to be the 192.168.1.10, and I'm going to add as a generic. So here, TeSys Island mod 1, okay. It's going to be the analog, it's going to be this one over here, okay. I will have the unit ID 1. This one has the unit ID 255, okay. So if we go back here, it's there. So unless using the model 1, this one, the channel is going to be 1. And then I'm going to add another one again to read the second model, Island mod 2. Okay, and you can see over here that shares the same IP address, because it's the same bus coupler, okay, but it's going to be different ID to access to this information. So here's going to be the number 2. Now, as I'm reading analog input IO, we need to follow this. Okay, so we need to read from this position to write to this position and read from this one. Okay, so have done this in the Excel. So analog 3204, I'm going to LAN 2, and this one is going to be only 1. It's going to be 8504. 8504. Okay, now let's start with the second channel. It's going to be the digital IO. So digital IO 8501, but it has a different bits. Okay, so reading different bits. So 8501, just double check. 8504. Is that correct? 8501. Okay, it's gonna be 1 byte. Let me just make some modifications here, because this one is not 100% right. 1. There we go. So now we need to read this one. So 3201. 320. It's gonna be only one word, okay? But they have different bits, so we need to check that when we are connected to the controller. Okay, 3201, 4, 5, 6, 7, and the other one is 8501, 8 and 9, and this is gonna be the same. So imagine that you have another digital input, the address is gonna be the same, but the unit ID is gonna be different, the same for the analog input. So let's go back to here. To this one, okay, and apply. So the other thing that I have done here, okay, in the other project is to use the analog, the digital outputs of the M221 to control digital inputs of the TeSys Island. So let me just copy part of that code so we can have it. Copy, run, paste, run. Copy, run, and paste, run. Oh, doesn't allow me to do it. Just bear with me a second. Copy, paste. Yes. Just to avoid doing extra things. Okay, so the outputs that I have configured on here, on the digital outputs, are going to be connected to the digital inputs of the TeSys Island, so we can check what is going on. So as you may know, if you check the other videos, we can create an animation table, okay, to access to the IO scanner. So we have the IO scanner over here, which is the status, and this one we can have the inputs and outputs, number objects here. So what I'm gonna do now is to define some names. Mode 01, analog input 1, analog input 0. This one's gonna be analog input 1, and mode 2, digital IO. Okay, and apply these changes. And over here, animation table, mode 1, and digital input. Okay, so we can see everything over here. And then what I'm going to do is to use the percentage M0 so we can control this part. And finally, output register here, mode 01, analog output. It's gonna have only one, mode 02, digital output, and apply. So we need to check now the number of bits and everything, okay? But let's go step by step. So mode analog output, mode, digital output. Okay, so what we're going to do now is to connect with the controller. Okay, it's over Ethernet, and see what's going on. So let's see now. Download this to the controller. Now we should be able to see something over there. Okay. Just wait for this to finish. Hopefully we should be able to connect and play. So programming, here you should be able to see there's some information. The other thing that I have done is to connect the analog output of the module, okay, to the analog input. So if I change the analog output here for, I believe it was configured in voltage settings, voltage, okay, and the output voltage. So if I'm not wrong, if I define 1000, you have the 1000. I don't know if this one is volts. Okay, two. So this one's going to be the 10 volts over there. So you can see here that the analog output is connected to the analog input, and you're seeing the same information over here. Okay. And the other one is configured as NTP. What's configured as input sensor, temperature sensor. So you can see here that it's connected and it's working. Now the other thing is how we can read the digital input and output. So binary. So I told you that the digital output, okay, just to show you, you can see the output over here and inputs. So if I activate one of the outputs over here, you take a look, digital output is going to be the bit 8 and 9. So, and if you take a look also here, it's going to be the 8 and 9. So I'm going to modify this as position 0, this one's in position 8, position 8, sorry. And there we go. You can see that the LED has turned on. This LED is related to the output 1, so you can see that it's going to be activated. So now I'm going to the position 9, which for the output number 2, and there we go, is on. So this is how you can activate both of them. Then to check the IOs over here, okay, I have activated this additional logic to activate the outputs of the PLC to the digital inputs of the controller of the TeSys Island. So press this one, as you can see over here, the bit 0, 1, 2, 3, 4 is activated, okay, and it's the same as you have here. 4, 5, 6, and 7 is in order. And you can see here in the top that is activated the LED, so we are receiving signals. Okay, and okay. So this is how you can easily integrate the TeSys Island to the M221 information, but this is just for the digital and analog IOs, so you can replace the TM3 in case you don't have it for these ones. Now, one of the things that you need to be aware is that, okay, below, is that we have a limitation of the amount of devices. Okay, it only allows you to use up to 16 IO scanners devices. Okay, I'll just copy and paste the same as you can see here from the ID 0 to the 15. So we can only have 16 devices. So if you have additional equipment on the network via module as TCP IO scanner, you will have a limitation here. So if we, at the beginning I mentioned that going to show you two different methods. So the first one we already seen. You need to define each module after the bus coupler, which is this one. Okay, will have a unique ID. So you need to play with the UnitID and the Modbus register that I showed you on the document. Okay, you can use this one, or you can use this one, okay, for the third-party function block guide. Okay, you can find the different modules, okay, and the different addresses that you have. Now, the other way to work with this is a little bit more harder. Okay, you can access to the bus coupler, okay, that has the M255, 255, the UnitID 255, but I don't remember how, but I get this information, I don't know from who. So thanks for the to the guy or the lady who has done this. But you have like each module, okay, of the TeSys Island have their own information to read and write, and the information is divided in bytes. Okay, so what it does, the TeSys Island, is to put the information in order, okay, one information next to the other, so you can read the bytes. So in this case, depending on the selection of the avatar that you have selected, okay, it will give you the amount of information that you need to read in bytes. So if you're using the analog IOs, you will need to read 5 bytes and write 2 bytes. It makes a little more sense here because each analog variable has 2 bytes, 1 word, okay, it's an integer. So in this here, in the analog IO, okay, 1 word, so is what you are using for the analog output. It's only 1. For this one, for the analog IO, for the input, it reads 5 bytes. Here you have 4 bytes regarding to 2 words, okay, they are for the analog input 0 and analog input 1. The extra bytes, I really don't know, but that is the information that you have. The other thing that you need to check now is the digital IO. So it needs only 1 byte for reading and 1 byte for writing, okay, and the information is organized in a different weight, okay. So here in the digital IOs, okay, for digital inputs, the first bit, okay, you don't need to read. You need to start with the bit 1, 2, 3, 4 in order to complete the digital input 0, 1, 2, and 3. For the digital output, okay, you just need to read the bit 0 and 1, okay, and it will depend on the previous model that you have configured how it's going to start this byte, okay, because it could be in the word, it could be the position 0 and 1, but in the next byte it's going to be the 0, 1. Again, it's going to be the 7, the bit 8 and 9, okay, so that's something that you need to be aware of. So what I have done is this. So in order to avoid having different equipments already configured, okay, what I have done is, okay, let's use just one equipment without using the IO scanner. So I can move the information that I read using this function block that I created over here to talk with the bus coupler, okay, which is this one, which is the first module that has the Ethernet connection. I need to define the ID, that the ID is just the index that I have here in the configuration. Then I need to define the amount of reading and writing that I need from this device, okay. Inside, internally, what I'm using is the Modbus function from read and write simultaneously. Otherwise, I found out that if I only want to write information, it looks like that the TeSys Island doesn't allow you to use those kind of function, Modbus function. That's why I'm using read and write at the same time. I'm going to show you what is inside the block. So Then what we need to define is, okay, if I'm going to read and write information from the TeSys Island into the M221, I need to define a specific location on the controller that nobody else have access or touch this information. So you need to define these variables over here. In my case, I have defined something similar to what is inside of the TeSys Island, just to have to be easy, but you can do whatever position you want. Then I have created two different function blocks that allow you to read information from each of the module, for the inputs, analog inputs or digital inputs. Okay, and the information that is precise here is the memory read and writing from this part. Okay, oops, sorry, from this part. Okay, it's just like using a pointer for the internal position of the controller. And then here you can see as an input, I have already created like some swap, okay? Because depending on how the byte is organized in the word, you probably can swap the information to easily read what you need to read, okay? So the only, it's not issue, but the hard part here is to identify which is the right word to read from the device, because that one is a manual calculation that I need to make. Okay, so if you're using the system word, you can use you need to read 2 bytes and 1 byte. So it will gonna be the opposite of what I'm going to do next. So here you can see the offset to read this information, and here is a manual calculation. Okay, if this is start, I need 2 bytes, then the next one is going to be 1101, and then I need to read this information. Okay, so it's a manual calculation that you need to do in order to figure it out where the information is going to be. So saying that, I'm going to show you the application, okay, the example project. So I created these 3 functions. The first one is the communication with the island. Okay, I'm using a read-write communication module. Okay, just to read the amount of information that I have configured over here. Okay, in this case, these are bytes, but here you can see the amount of words. Okay, that is the configuration that you need to do. Then in the digital input and output, I just was playing around with the swapping and how to read the data and not overwrite the information using some mask on information that is actual in the database. The same can be applied from the analog inputs and outputs. Okay, you have the code in there just to play and see what's inside. So what I have done here is I have called these function blocks. So it will give you the information easily if everything goes well. So there are a few things here, the configuration that I'm going to do with you now. So I'm going to connect with the controller and download this program, okay, just to show you how it works. But the main point here is that you need to make the manual calculation of the words to read. Okay, the advantage of doing this is that you only have 1 device, but probably it's going to be more complex code, okay, rather than using this, using the same UnitID. So the other thing that I didn't mention, and it's not in here, okay, is that you don't need to use the percentage MW999. Okay, you don't need to use this because I was playing around with this and I need this variable in order to share the data and exchange everything. Okay, so this variable, you don't need to use it in your program. Otherwise, if you are using it, you need to change this part of the code where you're using the percentage MW99. Okay, so let's connect to the controller. Download. Okay. and play. So configuration TeSys. So in here, the ID is not the unit ID. Okay, it's just the identification that we have of the device on the list of the Modbus TCP equipments. It's going to be the index 1. So here I have the number 1. So here I need to specify the quantity from read and write that can be obtained from here. Okay, this is not a manual calculation, it's based on this. Okay, on the selection. If you go over here, you should change that information. Okay, so nothing here. 4 and 2. So reading is gonna be 4, and this one is gonna be 2. Now, here I need to define a location in the controller where to store this data. So I'm going to use the same addresses that I have on the TeSys, just because I want. Okay. 1300. You can define this as a static, okay, constant variables, but it depends on you. Then what I'm going to do is to show you what I'm reading. So reading information. So if I execute this, enable and execute, I will be seeing, okay, I'm reading something. Okay, and you can see over here the information that I'm reading from the device, reading and writing. Okay, you can easily override this information manually, but the idea is to use those function blocks that I have created over here to easily find everything. So the next thing that we need to do is to add the functions for the different IOs. Okay, I have one module for analogs and the other one for digital. So I'm going to start with the analogs. The analogs, what it needs, okay, is to define where this information is going to be located. And if you can see over here, you should be able to see something here, okay, for the digital IOs and readings, okay. And you can see how the data is organized over here, okay. I have already done this calculation, how it's organized, so I believe I added over here. Okay, so this case for the analogs, okay, the first one is not used by this, but the second, yes. You can see the low part of the byte of the word is located over here, and this one, the high part. So what I have done is to make some kind of mask and organize the data together to easily show the information. So the start reading for this function block, okay, will start in this position, 1101. Okay, so reading 1101, but this reading is on my position, okay, in the position inside my database. So you can see over here, okay, reading this from the PLC, okay. The thing is that I'm using the same just to be much easier. That's why it matched the percentage NW 1100 with the one of the TeSys, okay. And here for the writing, okay, internally it knows how many bytes it needs to read. And for the writing, it's gonna be the position 1300. 1300. 1300. 1300. So now we should be able to enable this. You can see you are reading some information, -55 and 9. So if we connect to, let's see if I can connect to the device. Connect to the device, load from the device. Yes. So we can validate that we are reading that information. So diagnostic, analog IO. Okay, so you can see the input. Okay, so I'm reading the same Okay, 55, and here. So if I want to modify this, okay, let's just IO writing. I have added, I believe, here the IO. This is IO. So here I can define, for example, 1000, and you can see there's is writing this information over here, and I'm reading what I need to read. Okay, it's reading that one. So if I increase this to 10,000, it's gonna be the 10 volts if I'm not wrong. Okay, as you can see, it's almost the 10 volts that I have. Okay, but the information that I'm trying to read and write is the same. That's the important thing here. Okay, so if I reduce this part, okay, 8,000. This is what I want. This is what I get. Okay, there's all there, but the information that I'm trying to send is this. Okay, so that's important. So we managed to read and write using just one equipment on analog I/O. So now if we go to digital I/Os, we just leave it in there. We need to do the same for the reading and of this function block for read and write. So for the reading, okay, what I'm going to do is to check here which is going to be the information. So the other one finishes this one, but using 5, so the higher part of the byte of the word belongs to the next device. So it's going to be this one, 1103. But this 103 is the same as the one I have defined on the memory. In my case, that's why I'm using that byte, 1103. And the other one, 1301, which is the next word because this one is already taken. Okay, so here 1301, 1301. Okay, just bear with me. Okay, so okay, there we go. So if I enable this, we should be able to see things. I'm going to show you now the equipment. So I have the digital I/O. Okay, I'm going to try to activate the outputs. There we go, the output 0 and now the output 1 using this. Okay, turn it off and on. Okay, so now what I'm going to do is to try to read the inputs. So reading, writing, reading. Okay, I'm using these internal bytes to activate the output. So let me just turn it off. You should be able to see the LEDs over here and also see this on the other side. So let me just try first this and show you here. Output on this is not going to be shown here. It's okay. Status. No, it's going to be seen here. So okay, I'm going to activate this. Okay, you can see that the input the input has been activated. Okay, and if we go, we should be able to see this here. Why not? But it's physically reading something. Okay, and if I activate this one, you can see the other one is on. So I'm reading something and I'm reading this information over here. Okay, there we go, and there we go. Okay, and I'm reading this information that is activated. Okay, so what I've shown you today is the different ways that we have in order to control and monitor the TeSys Island. Okay, you have the possibility to access to each individual avatar ID, okay, which is going to be very straightforward. It's very easy to read and write information. The thing is that you have a limitation of 16 devices, equipment that you can have on the IO scanner. Okay. The other way is to use only the bus coupler, okay, the head of the TeSys Island. But it's a little bit tricky how to read and write information. Okay, that's why I created these function blocks to try to be easy to read information, but it's possible to do it. Okay, you just need to make sure that the address came from bytes, so the organization of the memory is in bytes, and you need to make the manual calculation to know which is the word that is need to start reading with the function blocks. Okay, that's the only thing that you need to be aware. So this is it for the integration of the TeSys Island with the M221 to replace the TM3 digital IOs and analog IOs. Okay, it's not oriented to make the starters or the safety functionalities that we have on TeSys Island. It's not oriented to that, at least now, but at least we have some tools in case we want to integrate it, different IOs if we don't have the TM3's models. Okay, so thank you very much for watching this video, and I see you on the next one.